Hey guys and girls, today I'm going to show you how to create Flappy Bird on the BBC Microbit. Okay, so why Flappy Bird? Flappy Bird is a really simple idea for a game and it's amazingly fun to play. It also teaches you quite a few elements of how certain Python code works. So we're going to be using Python to create this. So it will show you how to display text on the Microbit screen, how to use variables to keep track of score, how to display images on the Microbit screen, how to scroll images on the screen, and how to detect if the user presses a button. It will also teach you how to keep part of your code looping. So we're going to use a really good online resource, and that is createwithcode.co.uk. This will allow you to write code in Python and simulate it on a virtual microbit. Okay guys and girls, let's get started. The first thing we're going to do is go to createwithcode.uk. This is our online code editor and it's quite a nice utility. Okay, it has a built-in microbit simulator so we can test our code as we go. We don't have to keep flashing the microbit. Really nice piece of kit. So the first thing we are going to do is we are going to tell the Python code that we want to load a module, and that module is going to be the module that controls or allows Python to control the microbit, and that's really straightforward, and it's from microbit import start or asterisk. Okay, and that will allow Python to control the functions of the microbit, allows us to control the buttons and load the predefined images and so on and so forth. Okay. The next thing we're going to do is we are going to make our Flappy Bird. And what we're going to do is we are going to create the Flappy Bird game. So we're going to need a bird and we're going to represent that with a single dot. So on the microbit. So a single dot is going to represent our Flappy Bird. But the first thing you want to do, the very first thing, is create a welcome message. And you can do that using just a string. And we can display.scroll get ready, so we can tell the user get ready, the game's about to start. And what I'm going to do is I'm going to show you how to use the simulator. So all we do is we make sure we're clicked on to the code and we press Control Enter. So there we go, it brings up the microbit and you can see it says get ready ... and that's it. Brilliant. So we're now going to think about how we're going to make Flappy Bird appear. So the microbit, if we have a quick look at the microbit, it has 1, 2, 3, 4, 5 LEDs across and 5 down. So it's a 5 by 5 grid. Now that's fine, but we're going to play about a little bit and we're going to pretend that there's a possible 100 positions where the bird could be. So we can imagine that it's sort of, this will be the position 0 and this will be position 100 or 99 for instance. Okay. Now what we need to focus on is the y-axis, so the up and down axis, not the x-axis, which is left and right. And we're going to set the y-axis to position 50. So inside our code, we're going to create a variable and set it to the value of 50. And then we're going to add a line which will be sort of the LED position. So LED y equals integer y divided by 20. So let me just explain that. So if I'm saying that the top of the microbit is 0 and the bottom of the microbit is 99, then I need to sort of compensate for that and tell it exactly where I want that dot to be. So if I bring up a calculator and I do the value of y, which is 50, and divide that by 20, it gives me 2.5. But because I've got int in there, or int, what it's going to do is it's going to round it down to 2. So if I show you the microbit again, so the grid starts at 0. So this line here is actually 0. So if I'm going to go 0, 1, 2 on the y position, this is where I want my Flappy Bird to start. So that's why I'm doing that. I'm now going to put in the line of code that actually tells the LED where I want it to do. So I'm display.set pixel, so I'm turning a pixel on, okay, and this is the X. The 1 represents the X axis position. The LED Y is taking this number from the variable, okay, and then the 9 is the brightness, 0 being off and 9 being the brightest the LED can be. So it's going to start, and we'll show you. There. And the reason for that is obviously we're telling it to be in the x-axis at 1, so 0, 1, and then the y-axis of 2, 0, 1, 2. So that's where we want our little dot to start, our Flappy Bird to start. And I'm just going to tidy up the code as I go. It's always good to comment your code, tidy up your code as you go. I'm also going to hashtag out the display for now, just so that when we test the code, it doesn't keep popping up with get ready, because we know that works. So we're now going to get into doing some loops. So I'm going to put in a while loop. So while true. So this is while while the game started and everything's true, it's going to loop and continuously do whatever I put inside the while loop. Hopefully you've come across while loops before. If not, that's not a problem, but you should investigate them and see how they work. So I'm going to pop that code into here, and it all needs to be indented. So it needs to be indented by 1, so as that starts, and I can remove that. Okay, so inside my while loop now I have while true, while the game started, we want it to display our Flappy Bird, and then we want it to actually sleep or have a delay of, say, 20 milliseconds. Like milli or micro? Not sure. Okay, so there we go. So we've got our sleep in there. Okay. We put a delay in purely to stop the program crashing out or getting upset, giving the CPU too much to think about. So it will display the Flappy Bird, and then it will wait before it goes and does whatever else happens in the loop again. And what we want to do is we want to get our Flappy Bird falling. So we're gonna want some sort of gravity. So what we're going to do is we're going to make a variable called speed, and we can set that to 1 to start with. Speed equals 1. Okay, and then we can have it increment our speed every time it does something. So every time it starts, we can have it increment and get faster. So I'm going to show you what this does very quickly. Now you can see it's drawn a line. It's got dot 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 as it's dropped, and then it's caused an error and crashed the program. And the reason for that is we haven't told it to get rid of the previous dot. So we can do that by using display.clear, display.clear, and using parentheses. And the reason it crashed is because it went off the bottom of the screen, which we don't actually want it to do. So after our y increment of speed, we can just say if y is greater than 99, set y to 99, so it can never go below 99 or the bottom row. And we'd probably want to do that for the top as well, because it could possibly go off the top. Just make sure your indents are right. You can look at mine on screen and make sure that your code's indented correctly, or it will give you an error. Now at the moment the gravity isn't very realistic. It's going just in one constant speed, and we want to change that. So I'm going to change speed to 0. So it's going to start at 0, and what I'm going to do is I'm going to tell it to increment the speed by 1, but I don't want it to go faster than 2. So it's going to start at 0, go 0, 1, 2, and then it should stay at 2, sort of like a constant speed, because that will be the bottom of the screen Now, a lot of my students always say, well, I don't know how to indent my code. I always get confused. And a good rule of thumb is if you see a line end with a colon, what you want to do is the next line is probably going to have to be indented. So that's a good rule of thumb. It's also really bad programming not to comment your code. As you can see, my code's not commented and it looks a bit confusing. So what I'll do now is I'll comment my code and you can see it a bit clearer with the comments, and it does look a lot clearer with comments. Okay, so I've commented the code, so you can see that where my loop starts, I've got game loop. The part of the code that will speed up Flappy Bird as he falls, I've commented. I've put what moves the bird but not off the edge or off the top, and where we draw the bird and where our weight is. So for another programmer coming along and looking at that, it makes it an awful lot clearer. What I'm going to do now is I'm going to make Flappy Bird sort of move up and down when a button's pressed, and I'm going to use button A. So when I press button A, I want the bird to be able to go up and down. So up, sorry, because we've already got him going down because of the gravity, but we want him to be able to obviously fly up. So I've got, what I'll do is after display.clear, I will put a couple of spaces, and this is my code. So flap if button A was pressed. So what I want it to do is if button A was pressed, I want it to flap. So if button underscore A dot was underscore pressed, parentheses, speed will -8. So the speed as it falls is going 1, 0, 1, 2. We want it to go -8, so it will jump up. Okay, so that is that. And then what I'll also do is we want to have a score. So I'll create a variable called score, and I will set that to 0. Okay, and then I want a way to be able to see the score. So I'll use the B button for this. Okay. And I'm saying if button B was pressed, display.scroll, show a string of score, and then I'm going to add that to, I'm going to join that together, concatenate, and have a string score, the value of the variable score. So when B is pressed, it will show 0. Okay, and I can show you what we've got so far. So we've got get ready, ... Okay, and we should have a Flappy Bird, and I can move my Flappy Bird up by pressing the A button, and if I press the B button, it says score. Okay, so what we're going to do now is draw some pipes, so some of things to avoid, be able to avoid. And to do that, we're going to need a random number. So there's a module for this, and we can just do import random. So import random, and then that will allow us to, when we call that, to import a random integer. So drawing the pipes above the while loop, we're going to put a function. Now I don't know if you've come across functions before, but a function is a piece of code that we can call at any point during the game. So we can write it once and then call that piece of code just using its name. So here I've defined a function called make pipe, okay, which will draw a pipe. And then here you can see I'm calling it, so create first pipe, and I'm calling it here. So just write that and it calls the above code, which is really, really powerful. It's extremely quick. So this is how I've done it, define make pipe. And then within that, I've set a variable, a local variable, and it's important to know the difference between local and global. So up here, my y equals 50 is a global variable, which means I can call it anywhere in the program and change it anywhere in the program. Whereas within my function, I've got I, which is a local variable, which means I can only really set it and change it within the function locally. So global, local. Okay, so the first line is setting a variable called I, and it equals an image, and that image is drawn using these numbers. So there's 5 LEDs on the microbit, and I've got 5 sets of numbers, 1, 2, 3, 4, 5, and you can see here I've lit up the 5th LED on the first 1, then second row, third row, fourth row, fifth row, and they're not bright, but they're sort of in the middle range. Okay, I've put a gap in, so I've created a variable called gap and said random int, so I've called a random number, and that'll put a hole in the wall, and then telling it where to put the holes in the pipe, setting it to 0. And the reason it's set to 0 is it turns off the LED. And then here I've called the first pipe, so I can show you this, and it says get ready. We know that's working. I should turn that back off really. Okay. And the reason we didn't see the pipe was because I haven't actually told it to show it. It's actually clearing. In my while loop I've got display.clear, and the reason it's clearing it is because it's clearing all the LEDs. So we don't want that. We're going to get rid of that bit of code and adapt it to show the image okay, and it will show the image and clear all the others. So let's try that. And there we go. You can just you can see it. It's just a bit faint. It's because I've set it to be quite a low value. I could change these to make them really bright, but I quite like the subtle. It makes the game a little bit harder. So we now need to get the pipes to move towards the bird, and we're going to do that using a frame. And we need to keep track of how many times the main game loop has repeated. Okay, that's what I mean by frame. We're going to call that a frame. And then we're going to track that. So we're going to create a global variable up the top. Just make sure my simulator's not running. Okay, so global variable at the top, and we're going to call that frame. And we're going to equal that to 0. Okay. And then inside our while loop, we're going to increment frame by 1 each time it runs. Okay, so every time the program runs, we want it to increment the frame variable by 1, so +1. Okay, so we've got a global variable called frame. What's the point of having it? So we're going to create some constants. Okay, and constants are different to variables because constants don't normally change. Okay, hence the word constant. So we've got a delay 20, okay, which will always be 20. We're not going to use any others. Frames per wall shift, okay, number of frames between each time a wall moves a pixel to the left. Okay, so it will wait 20 before it moves. Okay, number of frames between each new wall. So we want 100 frames between each new wall, and frames per score 50, number of frames between score rising by 1. So it should be incrementally harder as we progress. So we've created the constants. We need to essentially use them. So we're going to come down and inside our loop, and we'll put it after where we draw Flappy. So we'll move that down a little bit. Yeah. So in here, I've put some code, and the code I've put is this. I'll highlight it just to make it a bit easier. So hashtag move wall left. Okay, so if frame % frames per wall shift equals I shift left. Okay, so I will explain this. So what these lines do, okay, is it checks the current frame number to see if the program should shift the wall left. Create a new wall or increase the score depending on the value set for the constants. Okay, for those 3 constants: frames per wall shift, frames per new wall, and frames per score, respectively. Okay, they do this using the it looks like a percentage sign, but it's actually called modulo operator. Okay, modulo is it's a little bit complicated for beginners. So the easiest way to sort of say what modulo is it's used for remainder division on integers. Okay, it can be used for floating point numbers, but don't get caught up in that. If you want to know more about that, have a look online at Modulo, Python Modulo. Have a look at things like Stack Overflow, which is a really cool website for coding, and you'll get some better ideas on what Modulo is used for. So our game is pretty much complete, but we do need a game over, a way to end the game, and that's going to be killing off Flappy Bird when he collides and has a collision event with a wall. So in here, just above move wall left, we'll put our collision event. So here's our collision code. So we just do if I get underscore pixel 1 LED Y, okay, and essentially what we're doing is we're checking to see if we hit the pipe, okay, and then this is really nice. We can display.show image.sad, okay, so display.show image.sad, which is a built-in image, so we don't have to do what we did by drawing the image manually. It's just a built-in microbit image that gives a sad face. You could do a string and say game over. You could do anything like that, whatever you want. Okay, and then we're going to sleep. We'll have a delay for a long delay, okay, and then we'll show the user the score. If you then want to reset the game, you just press the reset button on the back of the microbit. That'll be fine. So let me show you what we've got. So here we go, get ready. I'll get my little A button ready because it's going to be quite quick. And you can see, and it is really hard. It's really, it is quite frustrating. You've got to try and keep that bird up, get him through the pipes, and get that high score. Okay, but there's no point in designing a game unless you're going to test it on the actual microbit. So let's go over now and have a look of how to do that. So to get it onto the microbit, all you really need to do is you can copy this code into the BBC website, or when you run it, there is an option here to download the hex code and just drag and drop it onto your microbit. I'll do that now. Let's take a look. Okay, guys and girls, so I've got the code on my microbit, and let's press the restart button, and it says get ready. And here we go. Game over. Reset it. Okay, it is quite a frustrating little game, to be honest. Okay, it does display the score. Oh, score 3. So see how well you get on. Remember to like, comment, and share. I've put the complete code down below for you, and also if you've got any questions, remember to comment.